All right, welcome. Today, we're going to untangle a networking technology that's all about turning a digital traffic jam into a superhighway. We're talking about EtherChannel.
You know, it feels like it should be simple, right? You've got two network switches, you need more speed, more backup, so you just plug in more cables. Easy. But then, nothing happens. In fact, you might even notice some of those little link lights are off. The ports are just sitting there, blocked. So what gives?
Okay, so here's how we're going to break this down. First, we'll figure out what's causing that traffic jam in the first place. Then, it's time to build our EtherChannel superhighway, and we'll look at the 3 different ways you can do it. After that, we'll peek at some of the more advanced stuff and finish up with how to keep everything running nice and smooth.
All right, let's dig into that first big question. Why doesn't plugging in more cables just work? Well, it all boils down to a really important safety feature that's built right into pretty much every modern network. And that feature, well, it's called the Spanning Tree Protocol, or STP for short. Now, STP is usually the hero. Its whole job is to stop these disastrous things called network loops from happening. But when you plug in multiple cables between 2 switches, STP looks at those extra connections and thinks, whoa, danger. It sees them as potential loops. So to play it safe, it just blocks all but one of them. You're left with one working link and a bunch of perfectly good cables just sitting there doing nothing.
So, how do we fix this? How do we actually use all those cables we ran? Well, that's exactly where EtherChannel comes in. Think of it like this. We're about to build a brand new multi-lane superhighway for our network data.
EtherChannel, and you might also hear it called a port channel or link aggregation, they're all the same thing, is basically a really clever trick. What it does is it takes a bunch of physical cables, up to 8 of them, and it bundles them all together. And here's the magic part, it makes them look like just one single connection to Spanning Tree. So STP is happy, right? It only sees one path, no loops, and we're happy because we get to use the combined speed of all those cables.
And the benefits? Oh, they're huge. It's not just about more speed. You get awesome fault tolerance. If one of those cables in the bundle gets cut or unplugged, no problem. The traffic just keeps flowing over the remaining links with 0 downtime. Plus, it intelligently shares the load across all the active links. Honestly, it's a super cost-effective way to beef up your network without having to buy brand new, faster switches.
Okay, this sounds great. So, how do you actually set one of these things up? Well, you've got 3 main ways to do it. 2 of them use some clever automatic negotiation, and 1 is just straight-up manual. So those 2 automatic options are protocols called LACP and PAgP. Now, the biggest difference you need to know is this. LACP is an open standard, IEEE, so it'll work with pretty much any brand of switch. Cisco talking to a Juniper, no problem. PAgP, on the other hand, is a Cisco thing. It only works between Cisco devices, and they each have their own lingo for their modes. LACP uses active and passive, while PAgP uses desirable and auto. And here's the deal with how those modes actually talk to each other. For a connection to happen, at least one side has to be, actively trying to form the channel. It has to be the one to start the conversation. So for LACP, active talking to active works, and active talking to passive works. But if you set both sides to passive, well, they'll just sit there, each waiting for the other to do something, and nothing will happen. It's the exact same idea for PAgP with its desirable and auto modes.
And then there's that third option, the good old manual on mode. With this one, there's no negotiation at all. You're just telling the switch, hey, these ports, they're an EtherChannel, period. This is super useful when you're connecting to something like a server, which might not speak LACP or PAgP, but can still handle having its links bundled.
Actually configuring this stuff is pretty straightforward. It's really a logical process. Step 1, you grab the interfaces you want to bundle up. Step 2, you set up their basic configuration, like making them trunk ports. 3, you tell them which protocol to use, we'll say LACP for this example, and then finally, step 4, you put them all into a channel group and set the mode to active to kick things off. All right, so now that we've got the basics down, let's dive a little deeper. Everything we've talked about so far, that's what we call a Layer 2 EtherChannel. It basically acts like one giant switch port, but you can also create something called a Layer 3 EtherChannel.
So what's a Layer 3 Etherchannel? Well, instead of acting like a switch port, it acts like a routed port on a router. You don't have to mess with switch port modes or VLANs at all. You just give an IP address directly to that logical port channel interface you created. This is absolutely perfect for creating super fast links between your core routers, or between a router and a big Layer 3 switch.
Okay, another key thing to understand is how EtherChannel actually balances the traffic. This is super important. It doesn't just send packet 1 down link 1, packet 2 down link 2, and so on. That would be a mess, because things could arrive all out of order. Instead, it balances based on something called flows. A flow is basically one conversation. So think of it like your entire download of a big file from a website. All the packets for that one download will stick together and go down the same physical cable. That's how it makes sure everything arrives in the right order.
Now, because it's balancing these entire conversations, or flows, the traffic isn't always split perfectly 50-50. The switch uses this kind of math equation called a hashing algorithm to decide which conversation goes down which link. If you have an even number of links, like 2 or 4, it usually ends up being pretty balanced. But if you have an odd number, like 3 or 5 links, you might notice that some links are working a little harder than others.
So you've built your awesome new superhighway. What's next? Well, the final piece is just making sure it stays up and running. EtherChannel is incredibly powerful, but you gotta know it can be a little picky. The absolute #1 golden rule for troubleshooting EtherChannel is consistency. Every single port you put into that bundle has got to have the exact same settings. I mean, everything. The speed, the duplex, the switch port mode, whether it's access or trunk, and if it is a trunk, then native and allowed VLANs have to match perfectly. If even one of those things is different on one port, that port just won't be allowed to join the party. Luckily for us, modern switches have a built-in safety feature, which is a lifesaver. It's called the misconfiguration guard. And what it does is, if it spots a major mismatch, like, say, one side of a link is configured for EtherChannel but the other side isn't, it'll just shut that port down and put it into what's called an error-disabled state. This is a good thing. It stops those dangerous loops before they can even start and saves you from some really nasty headaches trying to figure out what went wrong.
So when you boil it all down, EtherChannel is just a really smart and powerful way to solve a super common network problem. It's all about taking a bunch of smaller, slower roads and turning them into one big, strong, and reliable superhighway for all your data. And the best part is, you get more speed and backup without having to buy all new gear.
And that's EtherChannel in a nutshell. So it leaves me with one final question for you. Think about your own network. Where are the biggest bottlenecks? Where's that one spot where a brand new superhighway could really open things up? Something to think about. Thanks so much for tuning in.